Okay, this is the other big thing for ionic equations. This is in predicting what will happen in electrolysis. Now to do this, we have two types of electrolysis: molten ionic compounds and aqueous ionic compounds. The important thing about them being molten and aqueous is that the ions are free to move and carry the charge. In a solid, they cannot, so nothing happens. Now, molten is fairly straightforward. So let's take a few examples. So I'm going to do lead bromide. So let's look at the ions. So lead bromide, lead, as we can see, is a charge on the ion of +2, and bromide, as we can see, is Br-. So what I tend to do, I write down the ions with the charges here, and then positive ions will move towards the cathode, negative ions will move towards the anode. Now, this is the reverse of bonding because we're going from ions to elements. So this time then, if we've got a lead ion to become lead metal, it's got to gain electrons. So this is reduction. Now, obviously then, bromide, because it's negative, it's got to lose electrons. So that will go to Br plus E-. Now, bromine, because it's a halogen, has to be Br2. So we need 2 bromide ions, so we lose 2 electrons. And this is called oxidation. Now, do the same with zinc oxide. Zinc, as we said previously, it's got a charge of +2, and oxide, it's got a charge of -2. So, look what we got. We've got Zn2+, and we've got O2-. Zinc ions will move towards the cathode, and oxide ions will move towards the anode. And here we will get loss and gain of electrons. So zinc, because it's a positive ion, will need to gain electrons to become zinc metal. So it will need to gain 2 electrons. And that, as we said, will be reduction. Oxide ions, on the other hand, will need to lose electrons. So it will go to an oxygen atom plus 2 electrons. Now, we know oxygen goes round in molecules of O2, so we will need 2 oxide ions, and then we need to lose 4 electrons. And that will be oxidation. Now, molten electrolysis is no problem because you've only got 2 ions, so there's no problem there at all. Now, when we look at now electrolysis, aqueous electrolysis, we've got a completely different kettle of fish. And the reason is because we don't just have 2 ions. So, simple rules, first of all. So, first of all, because we've got an aqueous solution, we must include water. So we've got hydrogen plus hydroxide ions. Now, the rule for what's released at the cathode, the negative electrode. So, in that case, it is the least reactive positive ion because it requires less energy. At the anode, the positive electrode, it will be hydroxide ions released unless a halogen, i.e. chlorine, fluorine, bromine, iodine is present. And then the fourth thing is you need to look at the type of electrodes. Sometimes if you've got a metal anode, that will dissolve and go into solution as an ion. So we need to watch that. So let's look at a few examples. So, sodium chloride solution. So, first of all, from sodium chloride, sodium, as we can see, is positive ion and chloride is a negative ion. So we can have sodium plus chloride and also present from water, OH minus. Now, all the positive ions will move towards the cathode. All the negative ions will move towards the anode. But not everything will be released. So, at the cathode, if we look at the cathode, we've got sodium and hydrogen. If you look at sodium, it's right up here at the top of the reactivity series. Hydrogen's way down here. So the least reactive is hydrogen, and that is what we released. So sodium won't be released, hydrogen will. So hydrogen goes to a hydrogen atom. To do that, it needs to gain an electron. Now, hydrogen we know is H2, so we need 2 hydrogen ions and we need to gain 2 electrons. Now, gain of electrons, as we know, is reduction. Now, similarly, at the anode, and the rule being there, hydroxide is always released unless we have a halogen. Now, as we can see there, you've got chloride ions, they're halogens, so they will be released. So Cl minus goes to Cl plus an electron. Chlorine we know is diatomic, so it's Cl2, so we'll need 2 chloride ions and to lose 2 electrons, and that will be oxidation. So it's the choice thing here. Now the other thing is, as we are removing hydrogen and chloride ions, what's happening is that what is left is sodium and hydroxide ions. So NaOH forms in solution. So what happens there is what we are left with. Now let's look at zinc sulfate. So zinc sulfate, again, charge on the ion, zinc is +2. Sulfate, as we can see, is 2 minus. So we've got Zn 2 plus, sulfate 2 minus, hydrogen and hydroxide from the water. And as always, positive ions move towards the cathode, like so, negative ions towards the anode, like so. Now what will be released at the cathode? The least reactive. So if we look here, here is zinc and here is hydrogen. So again, hydrogen is least reactive. So zinc will not be released. So as before, H plus we know is going to, hydrogen ion is going to form a hydrogen atom. To do that, it's going to gain an electron. Hydrogen we know because it's diatomic, so it goes around in pairs. So 2 hydrogen ions need to gain 2 electrons, and we know this is reduction. Now, what's going to be released at the anode? we know it's going to be always hydroxide unless sulfate is released, unless halogen is present. So sulfate stays in. So effectively now hydroxide, this is one that needs to be remembered. 4 hydroxide ions go to 2H2O plus O2 plus 4E minus. And this is reduction. I said you need to remember this because it's too complicated to work out. Now, effectively, we are removing water. So zinc sulfate remains behind. So basically this time, removing water. So the solution becomes more concentrated. And that's just because we're removing water. Straightforward as that. Now, let's look at a couple of others. Right, copper sulfate with carbon electrodes. So, our ions. We've got copper, and copper, as we can see, is 2+. Sulfate, as we can see, is SO4 and 2-. So, Cu2+, SO4 2-, H+, OH-. Now, as we said, all positive ions move towards the cathode, all the negative ions move towards the anode. Now, what's going to be released? Well, let's look at the reactivity series. Here is copper, and here is hydrogen. So copper is less reactive than hydrogen. So our copper ions 2+ will go to copper, and to do that, as we know, we need to gain 2 electrons, and that's going to be reduction. What's going to happen at the anode? Well, we've got hydroxide and sulfate, so we've got a hydroxide ion here. That will be released instead of sulfate. So, as I said before, this equation 4OH- goes to 2H2O plus O2 plus 4E-, and this is oxidation. Now, effectively, we are removing copper and hydroxide ions. So what's forming in here is this. So H2SO4, which is sulfuric acid, forms. And as we're removing copper ions, colour goes from blue to colourless. That's because we're removing the copper ions. Now, if we change certain things, if we change the electrode, it has a completely different effect. So as before, copper sulfate, Cu plus 2, SO4 2-, hydrogen and hydroxide. Now, positive ions to the cathode, negative ions to the anode. What will be released? Well, we know copper is going to be released here. So Cu2+ goes to copper, which we know to do that we need to gain 2 electrons, and that will be reduction. Now, the big change is what happens at the anode. At the anode this time, neither hydroxide or sulfate is released. Basically, what happens is the copper electrode dissolves. So copper is going to become a copper ion. So to do that, it's got to gain 2 electrons, lose 2 electrons, and that's going to be oxidation. Now, what happens is, so copper anode dissolves. Copper will obviously be formed on the cathode. Now, there'll be no change to the solution as copper is being removed at the cathode and is being replaced by the same amount of copper going in from the anode dissolving. Right. And there we go with that, ladies and gentlemen. So that endeth